think so. Okay. Good morning. Good morning. And today is the 10th of February. So where are we? Where are we? Today we'll be rounding up lesson three. Lesson three, we'll be rounding up lesson three today. So I think we are one class behind, but it's fine. We will cover up. And if you can see my screen, you can see I have the Canvas calendar on my screen. So at the end of today's class, we'll also have a class reflection activity um, to round up the lesson three. And I am expecting your Zyvox assignment for lesson three on Friday. So it's due on Friday. We will take one of the labs as a class, I think a class exercise today. We have the time. So if you have any questions, any problem at all with any of the activity, please let me know. And I'll also be holding the virtual office hour tomorrow. So you can always pop in to ask your questions. That being said, let's move to what we have to do today. So we're rounding up lesson three. And if we go to the lecture notes, so we have to round up the third part, operation and math function for lesson three. So we started this topic on Thursday, like this particular presentation on Thursday. And last Thursday, we discussed the different operators that we have or that we use in Java. The compound operators, which could also be called the augmented operators. We also have the increment and decrement operator, which we discussed, and how the order of execution, how does the compiler process this kind of command, this kind of instructions when you give the computer. So we have the pre and the post. So what happens in the pre? What is the order of execution in the pre, and what is the order of execution in the post, either increment or decrement functions or command. So I don't know. Do you have any questions? Any questions before we move to the other concepts for today? Okay, let me see a thumbs up if there's no question. At least I am sure. So nobody's willing to turn on their video. I'm sure we are on the same. Oh, thank you. So today we will be starting our class conversations with the numeric type conversion. We also call that casting. What does casting mean? Casting means you are converting, you are changing from one data type to another data type. And this is a very useful concept, a very useful concept um, in any programming language, However, very important in Java programming language. One thing you need to keep in mind that this type of conversion is only applicable for numeric data type. When we talk about numeric data type, what are we talking about? Anybody willing to share that? Please use the chats. You can unmute yourself. When we talk about numeric data type, what are those data type? What are numeric data type? Anybody willing to share? Please don't make this class boring today. You can use the charts. What are numeric data type? When we say numeric data type, numbers, number likes. That's absolutely correct. Double, floats, int, long. These are numeric data type. These are the data types that you initialize with numbers. You are initializing them with number values. So this type of conversion only works for numeric data type. That is being emphasized. And we said it is the conversion. You're converting from one data type to another data type. So for instance, you're converting from double to integer or from integer to double. So um, so when we talk about, we will discuss, I think we should go and discuss the type, which will help us to understand this concept better. So what are the different types of conversion? I just explained that type conversion is also known as casting. That's a technical term in programming. Casting, you're casting, you're converting, you're changing from one specific data type to another data type. And we have two main type of casting. That is two main type of conversion. So we have the implicit conversion. When we talk about the implicit conversion, this is when we are changing from a smaller data type to a larger data type. For instance, look at on the lecture slide, you can see the last like the box we have here. And this is showing us, we talk about data type as how we save data in memory. How do we store data in memory? How we store data in memory from our previous classes. So we said bytes, shorts, ints, long, double, and these are taking they're taking different amount of space in memory, starting with bytes, which is the smallest, that allocate the smallest amount of memory, amount of space in memory. So implicit conversion type is you are taking from smaller to bigger. The container is like, for instance, you're converting an int to a double. That's just a simple description. So you're converting an integer to a double. So you're taking from a very small container and putting in a big container. That's implicit data type. In this type of casting, you do not need to do anything. The compiler understands the syntax. So once you type the command, the compiler understood the command. So you don't have to do anything. You don't, I wouldn't say you don't have to do anything, but you don't have a specific function, a specific syntax function to do an implicit or to make an implicit casting, for instance. So how does this work? How does it work? How does implicit casting work to the compiler? How does it work? So now we're declaring, for instance, we're declaring a double D equals, we're initializing it with 3, which is an integer. So we're saving 3, which is a whole number. A whole number. We're saving 3, that's just a word, not an integer. A 3, which is a whole number, we're saving it in a double format. So what does that mean? There is need for the compiler to understand, to change, yeah, exactly. Thank you very much. So the compiler does what? The compiler takes this value you've initialized and convert it to double. You don't have to do anything. Just give the command. And yeah, exactly. Thank you very much. That's wonderful. I'm reading your chat. So this type of casting is called type widening from the name, from the name, what comes to your mind? It is widening. From 3, it's taking like 3.0 or 3.000. So the compiler does what? The compiler widens the data type. So what the compiler does is like, oh, it's 3, so Now I'm being given the instruction to convert this whole number to a double, which needs a decimal point. There has to be value after the decimal point. So it's not value. There's no, I'm only giving an O number. So the compiler understood it that as, oh, I just converted to 3.00 or 3.0, for instance. So the compiler zero as a value after the original given value, after the decimal point. So, any question? Thumbs up if you understand what it's, how we'll initialize and how we convert in terms of implicit data type. So, thank you. So, what should we do? I hope you have your compiler, you have your IDEs open. Let's write a very simple and short, code to explain this folder. So do you have thumbs up if you have your IDEs open? Thursdays is always for coding. We know that. Thumbs up, thank you. So if you don't have it open, please. When you come into the open class, please ensure you have your IDEs open, because that's where we illustrate many of the things or many of the concepts we are discussing in class. So we want to name this, I want to name this type text, because that's the topic for today. So you see the way I'm arranging is still within my lesson 3, because we are still in lesson 3. So what should we do? We want to open our main. I'm sorry. Oh, let's start it. I like to write it. You don't have to. Once you type main, the compiler gives you a recommendation and you can pick. I do like to just have it written and get used to it. And don't forget, we talked about the inline, the endline, blocking formats, and this is moving my head of main, and this is my head of class. Please interrupt me if you have any question. So, I like to use comments because I want you guys to go back to the code and understand what has been done, the concept that has been discussed. So if you go back to your code, so I'm sorry, casting. So the purpose, we want to demonstrate the different types of casting. And we have discussed the implicit casting, which I want us to demonstrate using our programming environment. So what should we do? So we need to declare the variable and initialize the variable. So we're declaring a variable, and I want the variable to be double measurements, for instance, and I'm initializing measurements. I'm giving, oh my God, miss you. So I'm initializing double measurement as 200. As 200, what does this mean? I'm giving a whole number value to a double. A whole number, 200 is a whole number. There is no decimal point. Okay. So I don't have to do anything. So let's print it and see what the compiler will do. Let's print measurement and see. And the command to use when we have to print our system.how.print, and we are printing in a new line. We want to print in a new line. Measurements is, so we want to print what measurement is. And how do we do this? We have discussed this concept. We need to concatenate. We need to concatenate strings with other variable. So let's see what happens. See, if we are correct here. I see what a compiler does. What would the compiler do here? I don't know, it's taking a while. Okay, so can you see my screen? Thumbs up if you understand what just happened. Thank you. Perfect. So, exactly. It takes the compiler, you don't have to give any special instructions. The compiler takes the whole number and convert it to a double format and save it in memory as a double. So it had the decimal point and a value, which is zero because we don't have any value after the whole number, which is zero. So it's what this type of casting is also called the type widening. Don't forget, we are widening you're widening the type widening type of casting. So implicit casting use this mechanism we call type widening. Any questions? Any question? Okay. Thumbs up if there's no question, so we can move to the explicit casting. Thank you. So the explicit casting is actually the opposite. I do call it that. The opposite of the implicit casting. What happens here? You can remember I explained just a few minutes ago that the implicit takes from the smaller to the larger. So just integer is smaller, it takes to the larger. And here is the reverse. So it takes from the larger, you're saving. Here the larger value is compressed. So the larger value is compressed into a smaller container. It's just the opposite of what we've done. And this is also known as type narrowing. The other one was widening, and this one is narrowing because it compresses. So it is compressing the longer value, the larger value that we have into a very small container. So, for instance, it's compressing a double into an integer from data type. You understand what I just explained? Thumbs up if you understood this concept. Can you differentiate between explicit and implicit now? Thank you. So the other one is widening. This one is narrowing. So it narrows down. It narrows the value to suit, to fit into the new container. So what happens in this type of casting? It is actually different because you need to give the computer, you need to give your compiler some kind of command. You have to, the syntax has to be written in a way for the compiler to understand what it is to do. Unlike the implicit, well, you don't have to give a specific because it is just widening. The compiler just widened it. But here we need to give some kind of instruction. And what is the syntax here? What is the syntax? You have to bracket the new data type, when you're initializing, you have to put in parentheses, you have to include the new data type you want the value to be compressed to. Do you understand this? So what happens is like the new data type you want to convert to, you have to put that in parentheses. That's just it. You're giving that. Once the compiler see that instructions, the compiler understand what to do. Thumbs up if you're ready. Let's write a simple code to illustrate Yep, thank you. So we're gonna illustrate this other that type of casting as well. So now the first one here was I'm sorry, I don't do this. This is an implicit casting. And here we're talking about X implicit casting. And what happened here? Also, of course, we need to declare the variable. So we're declaring another variable here. And this variable we're declaring in. So I want to do something. Let's say who. So if I have this, what have I done? What will happen? Anybody willing to share? What will happen if I just, if I just declare this and initialize as as a floating point? I'm declaring an integer and I'm initializing the value as a floating point. What happens? Mm, let's say what happens. I want us to see what happened. Can you see what happened? Missing. It is missing. Something is missing here. Something is missing. So this leads to an error because the typecasting operator is missing. We already said they have to be a specific function. This is not like the implicit. This is the explicit casting. And this function is very, this syntax is very, very important. Because if this operator is not in our code, then we have this kind of error. It is impossible for the compiler to understand this. Do we understand? Are we good? Thumbs up if you understood what I just explained. So please don't make this mistake. This will lead to an error in your programming. So what should we do? We need to tell the compiler, you had to do what? You had to convert this to an int, and that's it. That's all we need. You need to convert this to an int, and this is called type narrowing because we are narrowing. So let's print this and see what happens. So we're printing num_sample, which is an integer now. So let's see. And the system.have there. I want to print in a new line. I don't want it to be on the same line with the implicits. So I'm telling you what I'm using each of the command, why not just system.how.print? Why system.how.print new line? Because I want the code to be run on a new line. So num_sample, it's apples. What is num_sample? So what should I do here? I need to concatenate with, I have to concatenate with the variable num_sample itself. And here I need to terminate my statement. So let's run that and see what happens, which we'll have to discuss some other point. Okay. Okay, what happens? I have 56, a whole number. 56, a whole number. Can you all see my screen? Why 56? Why do you think it's 56 and not rounding it up to 57 since it's 0.7? Why is the compiler not rounding this figure up? Can anybody explain that? Because this command is only narrowing. You're not telling the compiler to round up. And what the compiler does is to truncate. So it only removes thing after the decimal points. The instruction we gave the compiler is to convert this value to an integer. We did not tell the compiler to round up. And we will go in details when we talk about the mathematical functions we have in Java programming language. But here we're telling convert this data type to a whole number. And what the compiler does is what? Takes all value before the decimal points. It only takes the values before the decimal points, and it, that's what we're saying. It narrows. So it's going to narrow the values and only pick the ones before the decimal point and save in the new container. Any question? What happens if you cast it into a double again? No, of course. That's another line of code. You can do that. All you have to do is the same thing we did in the first example, implicit. Now you're declaring a double, not an integer. So we can do that. All I have to do is let's do that and copy. I'm just gonna copy and change the variable names. So I'm copying. And we want it to be nums apples. We want it to be nums apple 2. So that's new. And here, I'm just gonna say nums apple 2. And I have it here as 56. Nums apple 2. So if we run it, flip. You understand? Thumbs up if you understand what we just did. You can convert. You can, if as long as your code demands you to do that. The instruction you were given demands you to do that. You can convert from float to double, double to float, as long as the problem you're solving, the problem you're solving requires that specific statement or that specific command, you can always come. Any question on the types of casting? Any question? Thumbs up if there's no question, so we can go to mathematical functions. We just discussed that in a few minutes, and we can start writing some code. Thank you. So Java provides us many useful methods in math class for performing, basic, some level of intermediate, advanced mathematical functions. So what happens so I want us to read, to learn to read some Java API. So this is a specific class in Java. This is a specific class in Java, math class. And what are embedded in this class are the different methods, the different functions that we can use, mathematical functions in the sense that we can use in our Java programming language, that we can call on, we can embed them. However, we don't have to import the specific package. We don't have to import it. All we have to do is to call the class, because the package is a Java language package itself, compared to when we have to call the scanner package. Here we are not calling we don't have to import, but we have to call the class before we can use any of this method. Why? Why do you think we have to call the class before we can use any of the methods here? Use the chat, unmute yourself. I want this class to be as interactive as possible. I don't want to be the only one speaking. I want to learn from you guys as well. Why do you think we have to, we must call the math class before we can use any of the methods within this class? Because most of the methods in the math class are statics. So when you want to use a static method, you have to call the class. Then the compiler understand, oh, to do a math function? Okay, now you've called a specific class. Oh, and this is the method you're using. It's, I don't know how to explain it well, but it's that simple. Oh, you need a specific method, you need a specific calculation from where a lot has been saved. Makes sense. Thank you. So because it's static, it's within that class. You have to call the class to use the method. And you need to get familiar, familiarize with yourself with how to read Java APIs, and here, if you have to do any specific mathematical functions or mathematical commands and you're unsure of how to write the syntax, you have this documentations at hand. You have this documentation, and this is the syntax, how the method has to be written, and this is like the description of what happens. So if you have a specific problem you're solving that requires any of this method, number one, you must you must call the class. You must call the class. So a method in a math class must be called accessed by the math class itself. So you can just say int, I'm just giving an example in my head, like int here equals to power 2.2, for instance. No, you can do that. Int here equals to parentheses, you want to put your parameters 2, 2, you're telling it to do a power analysis. You cannot do that because you need to call the math class itself. And we will discuss how do we do that? How do we call the math class? So let's go back to our lecture note and continue. So like you see in the API documentation, we have the constants, constant math method. And I believe we have discussed some things about constants. So these are the constants, these are pi, it's always 2.14, whatever, it's constants. And these are the different, the different methods, We have more than this, but these are the most popular one, the most basic one we use in Java programming language. Any question? Any question? Do you understand why we must call the math class before we use any of the method within the math class? Because most of these methods are static. So we need to call, you need to call the class to understand it. Thumbs up if you understand this before we move to the end. Thumbs up. Thank you. I think only Habi and Shans understand this concept. I'm not seeing many hands up today. If you have a question, please let me know. Okay, so let's discuss few of the methods. We're just going to go through a few of the methods. You'll have that in your lecture note and on your Zybox to go in details. So we have the power, exponential method. How you and one of the function is the power analysis, the square root function. And what does this do? How do you declare it? It is very, very important. That's why we have the Java APIs documentation, if you have to use this, how do I declare it? So what happens? The base must be the first parameter here. I think that's just the simplest one. The base. Then the power will be all the parameters you're giving within this parenthesis to do a power analysis. So here, for instance, in the example box, I said you have to call the class. So how do we call the class? Maths, because that's the name of the class in Java. It is not a class you have. It's not a user-defined class. This is an embedded class in Java language. So the name is math. And because why is the M in capital letter? Why is the M in uppercase here? Anybody willing to share? Because it's a class. Don't forget our naming convention. Class, your class name and your file name, the first letter has to be in uppercase. Unlike your variable name, the upper the camel case, the upper camel case and the lower camel case, like we discussed in our naming conventions. So this is the math you're calling. Having this math is like you're calling that specific class. So what method am I using within this math class? I'm using the power method. And what is the syntax here? Within the parentheses, you have your base first, then the power. So here you're telling 2 power 3. So 2 is the base. And so that's 2 multiplied by 2 multiplied by 2. So if you don't want to have to write that long code, then 2 multiplied by 2, but you want to calculate the power 2, the power of 2, and you don't want to do 2 multiplied by 2, 2 multiplied by 2, what do you have to do? All you have to call is this function. This is actually simplifying, it's a way of simplifying our code, makes it more clear. Oh, once I see this, and the programmer is trying to calculate the power of 2. And a question, it's similar as well for the square roots. It's similar for the square roots. But here we only say, what is the square root of 4? And if we check, the different methods we have in math class, we already have the syntax of how it should be written, what is expected. Any question? Thumbs up if there's no question. Exponent methods. No question on exponent. Oh, thank you. So it's similar for rounding up. It's also another maths method within the Java programming language. And we have all these functions that we can round up. And they're different, the different uses, at what scenario do we use them, and the syntax of how to write them. This sounds convenient, yeah. Exactly. So the different methods, the syntax of how to write them. If you want to round up, you want to round up a long, you want to round up an integer, you're rounding up, a floating data type, like a double or float data type. Any question? So that's why we have, it's different from when we are casting. They're 2 different things. When we use the seal, for instance, and when we're casting, they're 2 different things. That's just it. You have so much. There are some examples. You can go through that. They are all in your lecture notes. If you have any questions, please do let me know. We here. And also, this is another function we have in math class. Meaning you want to calculate the minimum, you want to calculate the maximum. These are the things, and these are the different functions. These are the description of how it works. These are the examples. Please go through it. Let me know if you have any question. Any question before we check the time? We have 30 minutes until the end of the class, and we have to take us. Okay, any question? Thumbs up this if there's no question, and I'm expecting you to have your ID set up so we can write. Only happy? Only happy is I can only see the thumbs. Oh, happy. Okay. Eventually. More thumbs up so we can move to the next thing. Okay, Tony. Thank you very much. Perfect. So what are we to do today? What are we to do today? Let's come to our Zybooks, and I would like to take the 3.33 lab activity. That's the warm-up. We're declaring variable, we're casting, just putting everything we have done today into practice. All concept we have learned today into practice. Is our Heidi's open? Are we ready to go? So the first thing, we should read the instructions and say, what are we to do? What are we to print? So the first thing, this is an interactive program. This is an interactive program. Why? Because we are asking our users to provide some values. We're asking the users to provide some values. And we are printing those values. We are casting, we're casting I'm not sure we're casting no, 3. Okay, we're not casting here. Why? I thought it was casting in between. Okay, let's start. But this is, this is the output we're looking forward to have. This is the final output. So what do I do? What do I do mostly is I copy from Zybox directly. Well, I have done it, but I just copy. Class reflection code. Yeah, I'll provide that. Let's write this code. Let's finish this, then we'll go to the class reflection activity. So what I do is just to copy. This is one of your lab. This is very important as well. So basic inputs, that's the name I wanna get. So what I try to do is to have some creating a new class. Computer is a bit slow today. And I'm calling the class basic input because that's the name. However, I'll have to change it when I get back to Zybox. Yep. So because I'm copying and we just follow through the code. So the first line of the code, we have to input the scanner class. Why? Because this is an interactive programming, our interactive code that we will be asking, we will be asking our users to provide us some values. Of course, we open the class and the main, and we need to create the scanner object, to get those values, where we're telling us, we're telling our compiler here that these values will be imputed via the keyboard. Where are we getting the values that we want from the users? Of course, we have these variables declared on Zybox already, and because we are printing integer, double, I think, character, and a string. So we have this provided. And there was a question last week that said, do we have to declare all the variables before initializing them, getting the value from the user? And I was like, no, however, is a good practice. So I wrote this code exactly that way because I wanted to show that, yes, we can initialize and get the variable. We can initialize and get the value from the user at the same, on the same line of code. You don't have to declare before doing that. But however, I do say, for clarity's sake, it's the best practice. So we had to get the value, and it stores in this container user ends, the integer from the user. The double, it stores in this container. Of course, the character stores in this container, and we have the string that stores in this container. So what happens? What are we to do in step one? So I will want us to follow through. Yes. So what are we? Can you see my screen? Thumbs up if you can see my screen. You can still see my screen. I want to be sure I'm not speaking to myself. Thank you. So what are we to do? What are we to do in the first step? What are we to do? It's the user to input an integer, a double, a character, and a string. Store each value into a separate variable. Then output these 4 values. So we had to print these 4 values. That's the first step. And that's what the first output is going to do. It's going to print. It's going to print all this value that the user inputs. The second one, what should we do in the second one? Extend to also output 4 values in reverse. So what are we doing? We're reversing you. You tell the computer, provide this output this way, and you're reversing it. And the third step is to what? To extend, to cast the double. So we're casting the double into an integer. Exactly. That's what I wanted. That's what I wanted. That was what I was looking for to illustrate. So we had to cast this double. It is a double into an integer, 3. So let's run and see if our code is perfect. Don't worry, I'm going to upload this code on. I think we don't have much time. So to enter an integer, I want to use the same value, 99. The double is 3.77. Z as the character. Wow. Any question? Any question? Thumbs up if there's no question. Thank you. So I'll provide this code. I'll post it on our Canvas page, so do not worry. If you have any questions, please do let me know. I think that brings us to the end of lesson 3. Yeah, that brings us to the end of lesson 3. I hope we've been able to cover most of the things we discussed: constant, using math method, type conversion, binary strings. Okay. Random numbers, reading API documentations. Okay. Debugging, we've always been doing that, checking the code. Perfect. That being said, let's go to our assignments, because we have a class reflection due for today. To use my student view. So click on the class reflection for today. You can stay. I think that the code should be, yep, objects. So I'm pasting it on the chats. You have the class reflection code. Please ensure you submit. They are part of your grades. Ensure you submit. That's the way we take. That's what most of the time I'll be taking attendance in the class. This class attendance is mostly through using class reflection, or you have to put the code that was written in class, to submit the code that was written in class. So any question? Any question? Thumbs up if there's no question, so we can wrap the class today. Yeah. Thank you very much. Thank you. So if no question, that'll be end for today, and that's the end for lesson 3. Let me know if you have any concerns. I'll be taking the virtual, yeah. I'll be taking the virtual office hour tomorrow. So if you have any questions with any of your lab works or any of these activities, any of the concept of learning class, please come with your questions. You can also send me send me Canvas inbox message if you have any concerns. And please, your lesson 3 Zybox assignment is due for Friday. It is very, very, very important you submit your assignment before the due date. Else, Zybox will not be submitting your grades to Canvas. Also, it is important you go through Zybox, you go through Canvas to your Zybox assignments. Please don't go to Zybox.com to just do your assignments. Else, Zybox will not be reporting your grades, synchronizing your grades with Canvas. If no questions, have a wonderful day and see you on Tuesday. On Thursday, I'm sorry. On Thursday, we'll start lesson 4 on Thursday.
Thank you.
Thank you.
Thank you.
Thank you.
Thank you.
Welcome.